Welcome again to the course. I am excited that you've decided to join us on this journey to learn some advanced features when interfacing C++ to Qt Quick. This course is going to hit on 4 critical points. We're going to see how you can build your own custom C++ models. This is a very interesting topic, and we are going to see what it takes to be able to build your own models that you can use in C++. We're going to see how you can build your custom visual types and use them in Qt Quick. We're going to touch on singletons. This is going to be helpful when you want to only have one single instance of a class in your entire application. In the end, we're going to see how you can dig through the QML tree structure of your QML from C++. Sometimes you're going to need to do this, and we're going to show you how exactly you can do that. C++ models are a concept you're going to have to touch if you are building any serious Qt application. Your application is certainly going to be data-driven. You're going to have to store some data and need some way to display the data to the users. C++ models are going to come in handy in that case. The goal in the course is to help you build C++ custom models and be able to expose an API like this. You see here we have person model. Inside we have a bunch of persons, and it is a clean API. And when you define your person model like this, you're going to have a user interface like this. You see, we see the name that we specify here. You see, we see the favorite color in this box here, and we see the age of the user, and we are able to manipulate stuff. We're going to see how you build this thing in the course. Along the way, we're also going to see different ways you can use some simple models if you don't want to go full scale and build your own C++ custom models. We're going to see how you can use simple string list models, simple object list models, and we're going to see how you can make your models editable if you decide to go simple like this. Beside models, we're also going to show you how you can build your own custom visual types. If you see here, we have a logo type, and we can completely define this thing from QML, but it is backed by a C++ backend, and we're going to show you how you do this exactly. The first logo here is the green one you see on the right. The second logo here is the blue one you see on the bottom here. And you can control stuff from QML. I think this is very interesting. Next, we're going to move a level up and show you how you can build some list property API for your own visual type. We're going to build a stair chart like this, and you see that you can completely specify how it's going to look in Qt Quick. You're going to see what it takes to build something like this, and hopefully it's going to open your eyes on crazy things you can do with the QPainter API in C++. We're going to show you different ways you can work with singletons. Again, if you don't know what a singleton is, don't worry. We're going to touch on that in the next lecture. But they are a way to allow you to only have one instance of a class throughout the entire application. And we're going to see how this can be useful. We're going to wrap up the course showing you different ways you can dig through the structure of your QML tree and pick elements you are interested in, read the properties, modify the properties, and even call methods on these elements if you happen to need that. We're going to see how this can be useful too. Okay, I know this might be in the air. We're going to go to Qt Creator and show you the applications we're going to build and kind of spice up your appetite to jump in the course and learn these things. Okay, here we are. This is the model application that we're going to build. You see there is a bunch of files inside. Don't worry if this seems complicated. We're going to explain everything step by step. Let's look at the QML API that we have. Inside here, we have a person model. If you look at its ID, let's go down. We're going to find a list view inside. And we are using this model in this list view here. And here we are specifying how things are going to look in the delegate. Let's run the application and see what we get. You see that we have our list view, and inside we have the objects that we have defined in our C++ API. If you look at the model class, it is a completely custom model, and we are building it from the abstract list model. And we're going to show you how these things can be tied up to be able to use this in Qt Quick. This is pretty interesting. Let's go to the other application. This is a visual type. This is the bar chart that we saw in the slides. And you see, we are defining a stair chart here. We are inheriting QQuick painted item. Don't worry if this seems complicated. We're going to explain this step by step. Let's make this application runnable now and run it. And you see that we have our stator chart. Let's look at the QML API that we have. You see we have a stator chart here. We can give it a title, the background color. We can specify the stairs here. For example, if we bring up this stair chart again, you see the first bar here is yellow, green. We can make it red if we want it. Let's make it red and run the application again. And you're going to see that this is going to change. And it is being completely controlled from C++. You see our red here and our stair chart is here. You're going to learn how to do this. Okay, I hope this is enough to get you excited about the things you're going to learn. Let's talk about the requirements to get the most out of this course. This is an advanced course, and you need some knowledge about Qt C++ and QML to be able to understand what we talk about here. You also need some basic knowledge about how you interface between C++ and QML. In terms of Qt C++, you need to know about classes and objects. You really need to have an idea about how object-oriented programming works. If you know things like constructors and destructors, if you know how to work with signals and slots, and really the things you see here, you're going to be fine with the course. In terms of Qt Quick, you really need to have some knowledge about the items in Qt Quick, property bindings, using some Qt Quick controls components. You obviously need to know a bit about list models and list views. And if you know these kind of things, you're going to be fine. In terms of interfacing between C++ and QML, you need to be able to expose your C++ type as a context property. You need to register your types using many overrides of QML register type. You need to know a bit about list properties, default properties. You need to be able to propagate your changes from C++ to QML using the QProperty mechanism. And you really need to have an idea about how data is converted between C++ and QML. If you are rusty on any of these concepts, I recommend to take the basic courses that I have on Qt, and we talk about all these things extensively in those courses. I really do recommend to make sure you have the knowledge required to be able to make the most out of the course. Okay, now that the technical requirements are out of the way, I also want to talk about a few things. This course is very practical. I am going to spend most of the time in the IDE showing you how to wire things up. It's going to help you out if you also follow along with me and build these things as I build them and build your own understanding of how these things work. This is the best way you can learn. If you get stuck for some reason, try to compare your code to mine. The source code for each lecture is going to be attached to the course so you can download and see exactly what I did. And sometimes this is going to help you solve the problem. If you still can't solve it, you can search on Google, and there's a good chance somebody has faced the same problem as you, and you're going to find the solution and apply it. If this doesn't work, you can still ask a question on the course platform, and I'm going to do the best I can to help you out. Just make sure you ask the questions that are related to the course. We also have a community of Qt learners on Facebook. We have a Facebook group you can join. You see the link here. We have a Facebook page where we post updates to the course and some things you really need to know when you are doing some professional Qt development. These are the channels that we try to avail to help you learn the best. Choose what works best for you and use it at your best convenience. Okay, this is all for the introduction. In the next lecture, we're going to jump in and show you how you can use custom C++ models. I'll see you there. I'd like to welcome you on the C++ Custom Models chapter. C++ models are the recommended way to expose complex data sets that change frequently over time. We are going to start simple, showing how you can expose a simple string list model to Qt Quick, move a step forward and show you how you can expose an object list and use it as a model. On the Qt Quick side, we are going to show you how you can make your object list model editable on the C++ side and have the changes propagated to Qt Quick. And then we are going to show you the recommended and standard way of working with models from C++ and expose them to Qt Quick. We are going to decouple the model from the data source, and then we are going to enable your model to be completely usable in Qt Quick by enabling it to use list properties. This is a very exciting chapter, and I am confident by the time you finish it, you are going to be a much more confident Qt Quick and Qt C++ wizard. Let's get started. In this lecture, we're going to see how you can use a simple QString list model in Qt Quick. This is really as simple as it's going to get. The only thing you have to do is create a string list and put in some data like this. In this case, we are feeding it with the strings for the continents on the Earth planet. We are then exposing our model as a context property for use in QtQuick. On the QtQuick side, all you need to do is create a list view and assign this model as a model of the list view, and you say the name that you specified for the context property that you exposed. It is this simple. Let's go to Qt Creator and do this. Here we are in Qt Creator. We are going to create our project. It's going to be a QtQuick application as usual. We are going to call it string list model demo. Save it in a location on our drive. Hit next. Choose the Qt version you have installed. Choose the kit you want to use and finish. We want to change the title here to say what we are doing here. Let's go to the C++ side of this. Create our string list. We want to put in some data, Control A, Control I to align. Just the continents that we have on Earth. We want to include QML context and expose our data as a context property. We're going to say engine root context set context property. Let's say continent model and pass in the reference to our list. We can go to QtQuick, put in our list view. ID is going to be m view. It's going to fill the parent. Let's test it with the model that just contains a bunch of numbers. Let's say 20. The delegate is going to be something we have prepared before that we're going to put in here. It is just a rectangle. It has a height, a radius. We have a color, the border, and we tell it to be as wide as the parent of it. Inside, we have a text component that is going to display each item in the model that we have here. Let's run this and see what we get. We are going to get a bunch of numbers from 1 to 20. Let's go back to here and see what we did wrong. We are getting a compile error. We put a pound symbol here. This is a collection type, so we shouldn't do that. And we are fine now. Let's run. We have our model that contains the number from 0 to 19 because we specified that we want 20 items in here. Let's replace this with the continent model that we specified in C++ like this. Let's run again. And we should see our continents from Africa to Antarctica. This is all we have, and this is how easy it is to expose a string list from C++ and use it as a model in QtQuick. This is really simple, but it is also meant for simple cases. For example, if you wanted to change the data in this continent list, it's not going to be possible to update QML unless you explicitly reset the context property like this. I am not going to do this right now. We are going to be able to do this in a few upcoming lectures. For now, just know that when you have simple data sets like this in a string list and you want to expose to QtQuick, you can do it like this and use your model in QtQuick like this. In the next lecture, we're going to show you how you can work with object lists. I'll see you there. In this lecture, we're going to see how you can expose an object list that you have in C++ for use as a model in QtQuick. This is also relatively easy to do. The first thing you have to do is to provide your class that is inheriting QObject. You have to put in a bunch of properties for your classes. For example, here you see the person class has the names property, a favorite color property, and an age property that is an integer. Second, you need to provide a list of your objects. And here you see that we provide it as a person list. We add person objects to our list of persons. And then we expose this as a context property. The special thing about this is that these properties are all available for us in QML. If you look here in our delegate, that is going to be in a list view. We have access to the names here. This is the syntax we can use. You can also use this syntax here. We have access to the age. You can also use these two syntaxes. We also have access to the favorite color. We're going to go to Qt Creator and play with us. Here we are in Qt Creator. We are going to create our project. It's going to be a Qt Quick application as usual. It's going to be called Object List Model Demo. It's going to be saved in the usual location. Choose your Qt version. Choose the kit you want to use and finish. The first thing we want to do is to create our person class. Let's do that. It's going to inherit QObject. Finish. Go to the header file. Let's put in our names, favorite color, and age properties. We do that right below the QObject macro. Control-A, Control-I to align. Let's close this pane here so that you see everything. We want to generate the methods that are going to make the property mechanism work. Let's do that for the second property and do that for the third property. We want to move the fields in a private section on our class. Let's go down, create that, and put in our fields, Control-A, Control-I to align. We want to move all these method implementations to the CPP file. Let's do that. Age. We want to move these setters. Set favorite color, move to CPP. And set age, move to CPP. We want to move our public slots to the public section of the class. Let's do that. Take out this and align this a little bit nicely so that our class is good to look at. I think this is fine. And our person class is really ready. The next thing we need to do is go to main. Let's go there, include our person class. We need to create a list of our objects. We're going to say QList, QObject pointer. And we can do this because a person is also an object. Because we want to create our person objects on the fly, we want to go back to the person class and provide another convenient constructor that we can use that uses all the data immediately in the constructor. It is this one, person, and it takes the names, the favorite colors, and the age, and it has a parent here. Let's implement it in the CPP file, refactor, add definition in CPP, and we have our constructor here. We want to initialize our fields in our constructor here. So we put in our initializer lists like this. We initialize the parent and we initialize M names, M favorite color, and M age. But we need to change this because we are using underscores, M names, M favorite color, and M age here. This should do. Now we should be able to come to main CPP and add a bunch of persons to our person list here. Control-A, Control-I to align. And notice that the last parameter is the address of the QML application engine. So we should take this and move it to the top because we want our objects here to be owned by the engine. And when the engine is going to die, it's also going to clear out the memory location for this person objects. Now we have our list. We can expose it to QML as a context property as usual. We're going to say engine root context set context property. Notice that this is not auto-completing. This is a good sign that we forgot to include QML context here. And if we do this now and say set context property. We're going to see this here. We're going to say person model here, and we're going to say Q variant from value, and we are going to pass in our person list, just like this. And this way, we're going to have this model available in QML. We're going to go to QML, change the title here to say Object List Model Demo. We want to import Qt Quick controls and Qt Quick layouts, and put in a piece of QML that we have prepared before to save on some typing. It is nothing fancy really. It is a list view. It is filling the parent. It is using our model that we specified in here, person model. Let's copy it and paste it in again, just to be sure. It is the same, and it has a delegate that is really nothing special also. It has a height, a radius, a color, a border. Inside we have a row layout of components. We have a text field that is going to contain the names, and you see that this is how we read the names from the model. Notice that our model contains a list of person objects, and a person object has a bunch of properties. It has a names property, a favorite color property, and an age property. And these are the names of the properties that we are using in QML to fetch these properties. This is really easy once you know what to be careful about. Names here, age here, and favorite color here. We can run this application and see what we get if we are reading the persons that we put in the main CPP file. We have John Doe C++ and Mary Green that are starting. Notice what we have. We have our text field with the names. We have our spin box with the age, and we have this rectangle with the favorite color of the user. This is great, isn't it? And if you don't believe me that this is the data we have in C++, let's bring it up so that you can see the entire thing. John Doe, C++, Mary Green, Mitch Natson, Daniel Stan, and we have the same data set in here. You can actually copy all this and add a bunch of other persons so that you have a list that you can scroll in. Let's run again. And we can scroll and scroll and scroll. I want to bring to your attention that this should really be used when your data is in C++ and you can't use the data from QML. This is very similar to the way you do expose your model in QML using list model. Let's put a list model here and put in a bunch of elements, Control A, Control I to align. And you see that we are exposing the model from QML here. Now we can replace this model and use it instead of using the model from C++ like we did before. Let's comment it out and put in the new model. Notice that the roles are exactly the same. We have a names role, favorite color role, and an age role, which is exactly what we had in the properties here. So if we run the application, we expect to see the entire model here displayed in our list view. Let's do that. And you're going to see that it is exactly the same thing. So if you are using simple data sets like this and you can use a model from QML, I think it makes your code more readable and you should do it like this. But if your data happens to be coming from C++ for some reason, this facility is there for you to use. Before we wrap up the lecture, I want to show you that this syntax here to access the data in the model can also be used in case your model is coming from C++ like we did before. So I am going to bring this to the next line here and comment this and comment out the first line here where we access the roles in the model directly. I am going to run the application and you're going to see that they tell you that model data is not defined for 28 here. This is because we are using this QML model here, but we don't see this error when we use a model from C++ that is backed by a list of Q objects. Let's run the application. Okay, you see that we run without a problem. I just wanted you to be aware of the two syntaxes that you can use, but I do prefer this one that allows you to read data directly without doing anything else. Let's run again to prove that this works. And here we are, it is working. We are exposing our model from C++ and using it in Qt Quick. In the next lecture, we're going to show you how you can make this model here editable. For example, if we delete the data here and type something else and hit enter, nothing happens really because we didn't build in the facility to store the data when we edit like this. We're going to do this in the next lecture. I'll see you there. In this lecture, we're going to show you how to make your object list model from C++ editable from Qt Quick. There is no magic trick that we're going to be using. We are just going to be resetting the context properties whenever something changes in the model. Structure-wise, we are going to wrap our list of objects in a class called Object List Wrapper, and that object is also going to take care of initializing QML to have things organized nicely and to allow us to be able to reset the context properties whenever we need to do that. The code to reset the context properties is going to be wrapped in a method called resetModel like this, and we are going to set a bunch of context properties like you see here. On the QML side, all you need to do is to assign the model in your list view to be used. A warning about this approach: every time something changes in the model, no matter how big or small, we are going to trigger a reset of context properties. And you can imagine if this model happens to have a lot of data, it is going to be costly to do memory-wise and time-wise. So this is not the recommended way to store your data or edit your data if you have huge data sets that change frequently. We're going to go to Qt Creator and show you how to do this. Here we are in Qt Creator. We're going to create our project here. It's going to be a Qt Quick application. We're going to call it Editable Object List Model Demo. Hit Next. Choose the Qt version you have installed, the latest one. Choose the kit and finish. We are going to open the last project we did. Go where it is stored by clicking on Main here, showing Explorer. And we want to copy the person class because we don't want to type it again. We already have it. We're going to close that project. We open the location of main here. Go there, show in Explorer. Paste in the person class that we just copied. And we want to add existing files and put in person here. And we have our class. We want to open the class and go in the CPP file. And you notice that every time we change something, we emit a signal saying that we changed something. We don't need to do this here because we are going to be triggering the reset of the model every time something changes. This is a bad thing. You shouldn't do it when you have huge data sets, but we are going to do this here for the sake of you knowing that you can do this. We want to add our new class, which is called Object List Wrapper. Let's do that. It's going to inherit QObject. Hit Next and go to the header. We want to include QML application engine because we're going to need that. And we also want to include the person class that we have just imported from the last project. We want to go to the private section of the class, define a list of persons. We're going to say QList, QObject pointer. We want to use QObject pointer here because it allows data to flow easily from C++ to Qt Quick. If you put person here, it's not going to work. So let's put a warning here. Again, here we are going to use QObject pointer, and anytime we need to use a person object, All we need to do is cast this object pointer to a person, and we are going to have access to the methods and properties that we have in the person class. We also want to put in a QML application engine instance that we are going to use to load the QML. We need to provide a public initialize method. It is going to return bool. Let's go to the CPP file and implement this. We want to take the code we have in main. Let's actually comment this out because we want to have it for reference in case something goes wrong. Let's copy this, go to our wrapper, and do this. Let's see what we have. This is called mEngine, so we should change these instances to mEngine and say mEngine here. And if we fail to load this, we're not going to return -1, we're going to return false. And if we get here, meaning that we loaded the file successfully, we're going to return true. I hope this makes sense. Now in main CPP, we need to get rid of this first because we don't need it. We need to include our object list wrapper. We need to create an instance of it and call it wrapper. And we say if not wrapper, initialize. If we fail to initialize, we return -1, which is what we returned before here. Now we can get rid of this and actually test the app to see if it runs. And then we're going to move on with the new stuff. Let's try and build this. The build is successful. Let's run. And we have a window here, which means that the control to load and start our QML is moved successfully in our initialize method. Let's move on and make this better. We want to provide a getter for this list of objects. Let's do that. Provide a getter member function. It is going to return a list of objects. And if we go to CPP, we should have that right here. We want to make this method invocable because it can be called from QML. So we're going to say QInvocable, just like this. We want to add a private method that is going to populate our model with data. We're going to say void populate. We're going to implement it in the CPP file. And it is simply going to add a few person objects to our list of persons. We can do this because a person inherits Q object, and essentially a person is an object. Now we need to go to the constructor here and populate the model with data. And before we move to QML, we want to do something else. We want to set the context properties for our model to be available from Qt Quick. We're going to say mEngine because the engine is available here. Root context, set context property. And you see that we forgot to include QML context. We should do that here. Let's include it. QML context. Move to the CPP file and say set context property. We're going to call this my model, and it is going to be Q variant from value, and we are going to pass the list of objects, which is going to come from the method persons that we defined. If you go down here, this method returns a list of Q object pointers. Now we can go to main QML and actually use what we had before. We're going to go to the last lecture and look at the QML file we had in there, and we had a list view inside. I think we can copy it. so that we don't have to type it again. Let's copy, close the file here, go back to our QML file and put in the list view. We are going to need to import Qt Quick controls 2.4 and import Qt Quick layout. We have our thing here. All we need to do is say my model, and we should have access to the data that we expose here when we initialize our QML. I know there are a lot of moving parts in here. Let's build this to see that we have no errors. We're going to run it, show you that it runs, and I'm going to try and explain it again. Right now, we are just trying to have something running, and we are going to build in the feature to update the properties when they change in a minute. And you see that it is running here, so we are fine. We can close it. And to explain what is happening, you see that when we call wrapper initialize, let's follow it actually, follow symbol and a cursor. We follow here and we do the normal thing we did before, which is setting the context properties, loading the QML file using engine, and passing control back to main, where the event loop is starting here. And if we fail inside this initialize method, we're going to return false. And in main, we are going to return immediately when we return false from initialize. This is exactly the same thing that was happening before, but we passed control to our class here so that we can have an instance to the engine and that we can manipulate it later whenever we want. Now we want to allow people to be able to change the data in the text field, to change the age in the spin box, and to change the color in the rectangle here. But we're not going to do this now. I think it is enough to show you that you can change the data in the text field in the spin box. Anyway, we're going to be doing the color thing in a few upcoming lectures. Let's go back to C++ in the object list wrapper class and provide methods that are going to be called when you want to change something. For example, when you want to change the names of a person, when you want to change the favorite color, or when you want to change the age. I am going to put the methods in here immediately so that we save on typing time. We're going to implement them, refactor to CPP, refactor the implementation to CPP, and refactor the implementation to CPP. You see that we passed the index of the person that we want to change. This index is also going to come from QML. We want to test to see that this index is actually not out of bounds of our list. The way we do that, we say if index is greater than or equal to the size of the list of persons, we return because it's going to be out of bounds. If it is not out of bound, we want to capture the person at the given index. And because our list is storing objects, we need to cast to person pointer. This is what we are doing here. And we check to see that the name has actually changed. And if it has changed, we change the names field of this person object here. After we do this, we need to reset the context properties, but we have done that here. And I think that we don't need to be repeating the same code in different places. So I am going to extract this code to another method that I call reset model. This method is going to be private. So I'm going to say void reset model. I am going to implement it to the CPP file. I am going to remove this line here, copy it, or cut it out. Replace it with the method that I am going to move it to, and this should be fine. And after I change the names of the person, I am going to reset the model, which is going to reset my context properties. I hope this makes sense. I am going to do exactly the same thing with the set age and set favorite color methods. Set age is going to be like this, Control A, Control I to align. Exactly the same thing. And set favorite color is going to be like this. Now we have our model that we can use in Qt Quick. But there is one thing we need to do. To be able to call these methods, we also need to expose this object here to QtQuick. We are going to do that in the reset model method. And this is one benefit of moving repetitive code in one function so that you have one place when you can update things. We are going to say mengine root context set context property. Let's call it wrapper. And it's going to be this because this is the object we are in. We can go back to QML and in the text field, handle the editing finished signal. We are going to say on editing finished, and we are going to say wrapper. And you see that it is available here. We're going to set names. We're going to pass the index, which is automatically available in the delegate here. And we are going to pass in the text message that we get from the text field here. So we're going to say text, and this should be okay. Let's go back in the CPP file and put a debug statement when we change at least the name so that we know that our code is working. So we're going to say include qdebug and go when we change the names, say qdebug changing names to names. And let's spell this correctly. We can run this. Let's try to say Daniel Gray, and you see that the name has changed in the list, but we are not sure that it really changed. So I think a better way to really show you that this is changing is to provide a method that prints all the persons in the list that we have in here. We're going to go to the header file and provide a private method, another one that says print persons. We're going to implement it in the CPP file as usual. And I am going to just put it in here. It is very easy, so no need to spend time on it explaining. We are just looping through the persons, doing our cast because we are storing pointers to object. We turn that into pointers to person, and then we access the name, the age, and the favorite color. After we change the names, I think we should print persons to know the new data sets that we have. I think we should actually do this for all the changing methods. So we should do that after set age and after set favorite color. After you know that your code is working, you can remove these calls here. It is just an easier way for me to show you that the data has actually changed. Let's run the application. Change this to Daniel Gray. You see that we have John Doe, Mary Green, and Mitch Natson. Let's change the first one to Daniel Gray. Hit enter, and you see the data has actually changed. We want to also allow people to change the age from QML by moving the spin box here. We want to use the onValueChanged signal handler, and we want to say f value equals model age. We should use a triple equal sign because of JavaScript. If these two are the same, the data hasn't really changed, so we shouldn't do anything. But in the else clause here, we should actually change the data. We should say wrapper, set age, pass in the index, and set that to value. Let's run the application. Now we have John Doe, who is 32. Let's change them to Daniel Gray. Daniel Gray is 32, but if we increase, you see that Daniel Gray becomes 34, 35, 36. We are able to change the data in our model that is in C++ from QtQuick. To make this a little more interesting, we're going to provide the ability for a user to add a new person to the model from QtQuick. For this to work, we're going to go to the header and provide a method that is going to add a new person. It is going to be invocable and it's going to be void. This will do. Let's implement it in the CPP file. And what it's going to do, it's going to add a new person to the model. Let's copy this and just put in a new one here. Let's call this new person. And for this change to be reflected on the Qt Quick side, we want to reset the model. And we do that here. Now we can go back to Qt Quick and provide a way for a user to add a new person. On this side here, we have no layout, but all we want is really to add a small button below here. So we're going to add it. We're going to say button ID. It's going to be mbutton. Width is going to be parent. Width. Height is going to be 50. Let's do this. Text is going to be add person. And when it is clicked, we want to say wrapper add person. This will do. And we want to position this button to the bottom of the window. So we should say anchors bottom parent bottom. And this is going to force it to be to the bottom of the window. The bottom side of the button here is going to be to the bottom side of the window. Now we can run the application to see what we have so far. We have the app here. We have our button to the bottom. You click it, you see that we have a new person. We can change the name. Let's say Dan Gray. Hit enter, and you see that we have 4 people in our list now. The feature is working as we want. And this is exactly what we set out to do in this lecture. While this works, I really want you to be aware of its drawbacks. Every time we change the age, every time we change the names, we are calling reset model. And if you look at what reset model does, it is actually down here. It is resetting the context properties completely. So this is reloading your model, and it is really not efficient. A better way is to use the model classes that Qt provides to fully optimize these changes. In the next lecture, we're going to show you how you can use Q properties to improve on this a little bit. We're going to stop here in this lecture and continue in the next one. In this lecture, we're going to improve on the project in the last lecture and make the changes from the C++ side propagate to Qt Quick using the Q properties system. The main idea here is very different from what we did in the last lecture. In the last lecture, we were using context properties to let Qt Quick know of the changes on the C++ side. This time, we are using Q properties. The person class actually has most of the things we need for this to work. All we have to do is make sure the person class is using Q properties to expose its properties. And for any change that happens on the C++ side, we are going to emit a signal that something changed. And any bound property to that in Qt Quick is going to be updated. I know this might be in the air and not clear, but when we do a demo, you're going to see exactly how this works. So we are going to expose our list of persons as a Q property in object list wrapper, as you see here. And this wrapper of ours is also going to handle QML initialization to have things happen a little bit nicely. And we are going to reduce how much we rely on context properties to propagate our changes. On the QML side, we really aren't going to change that much. We are just going to use the getter for the list and assign that to our model, and it is going to work flawlessly. The good side about this method is that we only update the property that changes. For example, if we change the name of one person, we are only going to update that name in the list view, and that is going to improve a little bit on what we did in the last lecture, where any simple change triggered a reset of the context properties. The bad thing about this method is still that when we add items or do any kind of changes to the list, we are still reloading the entire model. So we are improving a little bit, but this is not perfect yet. A better solution, as I said, is to use the model classes that Qt provides, and we are going to look at that in a few upcoming lectures. Right now, we're going to go to Qt Creator and play with us. Okay, here we are in Qt Creator. We're going to create our project. It's going to be a Qt Quick application as usual. We're going to give it a name, save it in a location on our drive, choose the Qt version we have installed, choose the kit we want to use, and finish. Because this is going to be very similar to what we had in the last lecture, we're going to copy most of the things from that project. So I'm going to open it here. If you don't have it opened, please do open it. Go to the main CPP file, show in Explore. This is going to take us where the project is stored. We are going to copy everything in here, all the files. We copy, close this, and come back to our project here. Go to the main CPP file, show in Explore. And we are going to paste in everything. Main CPP is going to be overridden. Main QML is going to be overridden. We can actually close this and tell Qt Creator to reload everything. Yes to all, and this is fine. We also want to add the files that we just loaded. We're going to click on the project, add existing files, and we are going to select the classes that we just loaded. And here they are. Let's try and run the project just to make sure that it is working as expected. Here we are. We can add items and we can edit, let's say Dan Grayson, and hit enter. You see that they change. We can increase their age and you see that this is working fine. The only thing we really need to change here is to expose this list here as a Q property so that it is easily updatable from C++ to QML. So we are going to say Q property here. It's going to be a list, a Q list of pointers to Q object. Let's verify that. Yes, it is. We're going to call this my persons, just to make it different from what we had before so there is no confusion. And I can hit enter. What I want to do is to generate the methods that are needed for this to work. And I do that here. And you see that I have a list generated for me that I really don't want to use. I am going to comment this out. And I am going to look at the methods that were generated for me. The setter is not going to work on my persons. It's going to work on M persons we have in here. So we should say M persons and M persons here and M persons down here. The other location we need to change is in the getter. And I think this is fine. Now we can move the implementation to the CPP file and move the implementation of the setter to the CPP file to have things a little bit clean in here. We also want to move this setter here in the public section because that's where it should be. Remove this public slots thing here. Control A, Control I to align. The other thing we need to do is to go back to person and notice that we have the signals in here. If we go back in the CPP file, we find that the signals are commented out because we didn't need them in the last lecture. This time we're going to uncomment them because we are relying on them to propagate the changes on the person fields in here to Qt Quick. And we want to go to the wrapper here and see what we expose when we reset the model. We actually don't need to pass the model here anymore, but we still need to pass the wrapper here because we are going to use it to call methods like add person as we did here in the last lecture. Add person is here. Now we can go back to Qt Quick and change what we have here to say wrapper my persons to be our model. Before we run the application though, I think we should go back to object list wrapper and find the methods when we change something. For example, we set the name, we set the age, and we set the favorite color. You notice that we are resetting the model, but we don't need to do that because these changes are going to be propagated by the person class when we emit the signal to say that the favorite color changed. So we should remove these calls to reset model in these methods. I hope this makes sense. We remove it in the remaining methods and we can run. Let's see what we get. And you notice it turns out this syntax is not going to work when we use our model like this. Let's change this and use the other one. Model data names and say model data age. Go down to the rectangle and say model data favorite color. Let's build again. Close this. Run the application. And you see that we have the data we want. And if we change John Doe here, for example, let's try and see that our changes are being propagated. Do this, hit enter. You see that the data changes. It is exactly like what we had before, but the changes are not being propagated by resetting the context properties. They are being propagated coming from the Q property system we have here, because whenever we change something in the person, we are emitting a signal saying that we changed something. And if you add person, you see that we are adding the person. How this is working, it is using the add person method that we specified in here. Let's find it. Okay, and you see that it is resetting the model also, but we are not relying on this anymore. So let's run and add person. And you see that as we add person, the changes are not being propagated in here. And all we need to do now is not to reset the model, but we can emit the signal that we specified to the top here. My person changed. So we can emit that. Emit my persons changed and pass in the current list, which is my persons, M persons. Let's run. And we add the person. You see that we see the new person, and we can do the normal stuff we were doing on this object. Let's call them Daniel. Hit enter, and you see that we have Daniel here. Let's increase their age, and you see that we are 37, 8, 9, 40. It is working exactly as we want. And this is just another way you can expose your data. We are not completely relying on resetting the context property. And if you look here, we are not even exposing the model. The model is being exposed through the Q property system by using this property here as our model in QML. You see it here. And for this to work, the person class plays an important role because it is emitting a signal whenever something changes about these guys here. The names change, we emit the signal. The color changes, we emit the signal. The age changes, we emit the signal. And whenever we add something to the wrapper, we are emitting the signal saying that the list has changed somehow, and QML is going to update what it has to show about that list. This is all for this lecture. In the next one, we're going to see how we can use C++ models to do exactly what we do here. And that way is the recommended way. I can't wait to see you there. You now have a few tricks under your belt of ways you can expose your C++ data as a model to be used in QML. We have looked at how you can expose your data as a string list and use that in QML. And we saw how you can expose your data if it happens to be modeled as a list of Q objects. On top of that, we also saw how you can make your data editable and give you a convenient API that your users can use. But these things we saw have a few problems. If you happen to change something in your model, to have the changes reflected in QML, you have to completely reload the model. And this is a problem. If you happen to have huge data sets this is going to cost you a lot performance-wise in your application. In case of the string list model, if you edit something in your list, you're going to have to completely reload the model. And the same happens if you happen to add something and remove something from the model. When we have a list of Q objects and we want them to be editable, if you edit something, you have to reload the model. If you add or remove something, you also have to completely reload the model. So it is the same problem that we have with string lists. If we use the Q property mechanism, things improve a little bit. When you change one single data set, you only update that data set in the list view in QML. But when you add or remove an item, the entire model is reloaded again. And this is really not convenient. So I just want you to be aware of the costs that come with using these things. In scenarios where your data doesn't change that much, this can work really well. But if your data changes, you have to be careful with using these things. Hopefully now you know that this is really problematic if your data changes frequently. A better way would be to only update the piece of data that has changed in the model and reflect that in the view. And C++ models are exactly designed for that. And Qt happens to have a strong architecture, the model view architecture, that allow you to only update the parts that have changed in the view when something changes in the model. And that's exactly what we're going to look at in the next few lectures. Okay, what we have seen about string lists and object lists is really useful when your data doesn't change. But when your data is really changing frequently, you should look for something else. And what we are about to see in the next few lectures is going to help you out in that situation. Let's jump in the next lecture and show you how you can use C++ custom models. I'll see you in the next lecture. In this lecture, we're going to see how to work with proper C++ models and expose your data to Qt Quick. We are going to base our work on the abstract class called abstract list item model. A few words about this. This is the most recommended way to expose your models from C++ to Qt Quick. The benefit of this is that any change you do to the model doesn't cause the data to be completely reloaded on the Qt Quick side. For example, if you change the item number 5, only the item number 5 is going to be updated in Qt Quick. And this is very good performance-wise. The same also happens when you add or remove items in the model. Okay, I hope that you are convinced that this is the best way to do this. How do you do it? First, we need to remember that what we are doing is not that different from what we have been doing all along. We are still trying to model a list of persons and expose that to QML. But now we are wrapping our list of persons in a model that has a specific interface or contract that we have to respect. If you look here, we have our model here. You see that it is also a C++ class. We are inheriting Q abstract list model. And if you look inside, we have a bunch of methods. I don't expect you to understand any of this as of now. I just want you to be aware of what is available. You see, we have a few methods here: row count data, set data, flags, role names. These are the interface methods that we need to implement for our model to work correctly. We also have a bunch of other helper methods that we can call from QML. And you see that they are decorated with the Q invocable macro. And this is really the big idea. You inherit the correct class you want to model for. You put in the required overrides, and your model is going to work as it should. Now let's zoom in on the required overrides. You can see that we have row count data, set data, flags, and role names. These are the basic ones you have to implement for your model to work correctly. If you need more features, you can read more on the model that you are trying to work for, and you're going to find the methods that probably do what you want to do. A kind reminder is that these methods are meant to be used by the system. You're not going to be really calling these methods on your own. All you need to do is provide them and make sure they are manipulating your list the way you want it to be manipulated. The row count method is going to return the number of items in the model. So whenever the list view in QML needs to know the number of items that it's going to display, it is going to call this method to know that. And you see that the implementation is really simple. We are returning the number of persons in our list of objects. The data method is called when the list view is trying to display something in your model. For example, if the list view wants to display the names, it is going to call in here with the role that is set to names role, and it is going to return the name of the person at the index of interest. Again, I know this might not make sense yet. We're going to do a demo and you're going to understand how this is put together. The setData method is used to modify the data in our model. We pass in the index containing the information about the location of the item in the model. A variant contains the new value that we want to set, and the role containing the kind of data that we are interested in setting. And in the implementation, what we do is check the role to see what we are checking for. In here, if we are dealing with the age role, we check to see that the age is different from the age we pass in here. And if it's different, we set the new age and we say that something changed here. And down below, we check to see if something changed, and then we emit the signal to say that something changed in the model, and the list view is going to reload what it needs to display. We also have a flags method that controls the behavior of your model. In here, we are returning the Q item is editable to let the view know that this model can be edited. The last one here is really important. I know it looks weird, but what it does, it allows us to expose our own roles for use in QML. If you don't provide this, you won't be able to call names on your model or favorite color or age to set these to your UI components. The text fields, the combo boxes, or the rectangle where we are displaying this information in the Qt Quick user interface. So this is very important too. Okay, these are the basic things you need to be careful about for your model to work as it should. Once you have your model, you need to expose it to Qt Quick. We are going to use context properties for now. It is going to be available as my model, and we are going to create an object of it and expose it right here. In Qt Quick, there really is nothing special. We are just going to say my model, and the model is going to be tied to the list view. And if you look here in the spin box, when the component is loaded, we are reading the age from the model and assigning that to the value of the spin box. So we are going to read the data from the model and display that in the spin box. And whenever something changes in the spin box, the onValueChanged signal handler is going to be called, and we are going to take the new value from the spin box and assign that to the model. So what we are doing here, we are reading from the model and writing back to the model. This is very interesting. Okay, I know this might be a lot to take in. I just wanted you to have an idea of what we are about to do. We are going to stop here in this lecture. In the next one, we're going to open Qt Creator and build this step by step. I'll see you in the next lecture. In this lecture, we are going to build our C++ model, which is based on abstract list model to expose the data to QML. We're going to go to Qt Creator and do that. Here we are in Qt Creator. We are going to create our project. It's going to be a Qt Quick application as usual. It's going to be called Abstract List Model Demo. Save it in a location on our drive. Choose the Qt version. Choose the kit. We are going to use desktop as usual and finish. Because we are going to model a list of persons, we're not going to write the class from scratch because we have it from previous projects. We're going to just copy it. So I'm going to open the previous project, go where it is stored, show in Explore, and I am going to copy the person class, copy the header file and the CPP file, close the project, and close this. I'm going to come back where my project is stored, show in Explore. This is the location of my current project. You see that it is Abstract List Model Demo. I'm going to paste in my classes, person, header, and CPP. And I am going to add existing files and choose my files here. And they are going to be available in here for use. We want to add in our model class. We're going to add new C++ class. It's going to be called person model. It's going to inherit Q object for now. We're going to change this in a minute and finish. Let's go to the header. We want to include QAbstract list model, and we want to inherit this. Okay, so I'm going to put this in here, and down to the implementation, I want to initialize the class that we inherit like this. The first thing I want to do is to define my roles, and I am going to define them in an enum type that I'm going to define here. I am going to say enum, let's call that person roles, and we're going to put in a few roles here. We need a role for the names, so we're going to say names role equals qt user role. Let's do +1. This is how you define your enums for use with Qt. We're going to have an age role. I think we need a comma here. And we're going to need a favorite color role. Put a comma and take this one out. And this is going to be modeling what we have in the person class. You see, we have a names property, we have a favorite color property, and we have an age property. What we're doing here is going to allow us to use these properties as roles in QML and be able to assign them to user interface components. You're going to see how this works. The next thing I want to do is to provide my overrides that are going to make this a proper model. I am going to paste them in here. I don't really want to type all this, and you saw this in the slides, so there really is no point. Before I implement them though, I want to go to the private section and put in my list of persons. So it's going to say QList person pointer. And remember that I didn't include the class for persons, so this is a good time to do that. And you see that it is recognized now. Now I can implement row count, refactor, add definition in CPP file. The parent here is not going to be used, so we can decorate it with this macro to not get warnings from our compiler. And we're going to return mperson size, the number of items in the list. This is taken care of. The next method is going to be data. It is going to provide the model index and the role, and it is used to read the data. We want to implement it, refactor, add definition in CPP file. Let's do the others. Set data, refactor, add definition in CPP file. Flags, refactor, add definition. And role names, refactor, CPP file. I think we should start by the role names here because it's going to expose the roles that we are going to work with. You notice that the method is going to return a QHash class object taking int and qbyte array. We can create an object of this. I'm going to copy this, put it in here, and call it roles. Down here, we're going to say roles, names role equals names. What we are doing here, we are providing the names that are going to be used for these roles on the Qt Quick side. We're going to say roles favorite color role and call this favorite color. You can actually go to person and copy this. I think this is going to do. And by this, you might tell that I am a lazy typer. We're going to say roles, age role, and in QML, this is going to be available as age. Now that we have this, we can return roles. And this is going to take care of this method here. If you don't know what a QHash is, it is a matter of selecting it, hitting F1. You're going to be taken in the documentation. You can click on this help mode here, and you're going to see all about this class. It is a class that provides hash table-based dictionary, and you can read all about it here. I'm not going to go in more details because this is really not a course about C++. Flags is also an easy one, so we're going to do it right away. First, we want to check for invalid indexes, and we are not going to return any flags to use. If we have a valid index, we're going to return cute item is editable. I think this is the one we want to say that this model can be editable. Now we have two methods implemented. We want to go to data. The first thing we want to do is to check the bounds, and we are going to check the bounds like this. Control A, Control I to align. We are basically checking to see if the row of the index is less than 0, or if it's trying to point to a value that is past the size of the array. And in both cases, we are going to return an empty Q variant that really contains nothing. If we get past here, it means the index is valid. We are going to retrieve the person at the given index in the list here. So we're going to say person pointer person, and it's going to be equal to m% at a given index, which is index row. We are going to check the role here and return a Q variant representing whatever role we are trying to read from the model here. The roles that we have available are names role, favorite color role, and age role. So we are going to say if role equals names role, we are going to return the names of the person that we retrieved. If the role equals to favorite color role, we are going to return person favorite color. And if the role equals the age role, we are going to return the person, the age of the person, just like this. And these are going to be automatically transformed to Q variant types. Let's clear this. We need to do the setData method, and it is really not that different. We are just not reading the data as we did in this method. This time we are setting the data to the model. Again, we want to retrieve a pointer to the person object representing the index that we are interested in. I am going to copy this actually and put this here because it really is the same. This is the index that we pass it in here. And we are going to define a bool value that stores whether something has changed in the model. Let's set it to false by default. The next thing we want to do is to switch on the roles here. We're going to have three cases. We're going to have a names role. I actually want to copy this because I want to put it in a few times. I'm going to have favorite color role, and we're going to have an age role, and we want to put these in curly braces because they are going to be our blocks in here. And copy this a couple of times because I don't want to type it again. Let's put this here and let's put this here. For the names, we are going to check to see if the name that we are passing here in this Q variant is different from the names that we have in the persons list here. We are going to say if person names is different from the value to string, because that is stored as a string. If they are different, only then do we change something in our model. Once in here, we're going to say person, set names, and say value to string. And we are going to flag this bool here to say that something has changed in the model. This is going to be almost the same for the other roles. So I am going to copy this and put it in here. In this case, we are checking for the favorite color. If the favorite color has changed, we are going to set it. We're going to say set favorite color value to string and say that something has changed. We are going to put this in here. We are checking for the age, and we are setting the age here, and we are saying to int because the age is an integer. I also think we need to make this an integer. We don't need this break here, so we're going to remove it. And we want to check to see if something has changed. And we're going to emit a signal to let the view know that something has changed. We want to emit data changed. And you see that this method wants a few things. It wants a model index, the model index from the start to the finish where the data has changed. It wants a vector of rows. So let's give it what it wants. The start index is the index that we have here that we passed when we called this setData method. The end index is going to be the same. We create a Q vector of int and pass in the row that was passed in here when we called this method. And we are basically saying the data has changed. The starting index is this one, the ending index is this one, and the row that changed for that data is this row. And the view that is interested in this model is going to update if it needs to. We need to return true to say that everything is okay, and return false down here to say that something went wrong. And by now we have our methods implemented, and this should make our model fully usable from C++ to Qt Quick. But because we want it to be manipulable from Qt Quick, we are going to add a few helper methods that are going to help us do a few things. We're going to use the addPerson method here to add a few people in the list. We're going to provide a few other overrides of that. We're going to allow the user to remove the person, and we're going to allow the user to remove the last person, and we're going to implement that. Let's implement these methods. Refactor in person model CPP. We do the same. Add person with parameters. Remove person at a given index, and remove last person. Even though these methods seem self-explanatory, there are a few things you need to know. Whenever you add something to the model or remove something from the model, you need to call a few methods to inform the model that you are about to change it. Because we are trying to add rows to the model, the method we need to call is begin insert rows. It wants a root index, so we're going to give it QModel index. And the place we want to add the new person is going to be the size of the list of persons plus 1. So I am just going to put it in here. I am going to define it in a minute. So I'm going to say index, and the end is going to be the same. And after we insert the rows, we need to call another method that is called addInsertRows. You can check these methods in the documentation. What they really do is to prepare your model to accept the changes. Inside here, we can add the new person. So we're going to say mPersons, append person. We need to define this index. So we're going to say const int index equals mPersons size. We are going to add the new item at the index that is equal to the size of this list of persons here. And this takes care of adding the person to our model. It really is easy. The only thing you need to remember is to put these things in here because they make your model know that it is going to accept some new data and it gets ready for that. This addPerson override here is going to reuse the method that we just defined. So it is going to create a new person object and add it using the method here. And the same is going to happen to this one. We create a new person object and add it to the model. The remove person method is really like the addPerson method. We prepare the model to remove the rows. And after we're done with removing something, we call and remove rows. And in the middle, we remove the item at a given index. This is a method that is available on the QList class. And removing the last person is really easy. It's going to be remove person. And passing in the index we want to remove for. The last index is going to be the size of the list minus 1. Let's do that. And ladies and gentlemen, our model is ready to be used in Qt Quick. But before we leave, let's go to the constructor and add in a few persons, Control A, Control I. I noticed that this lecture is getting pretty long. We're going to stop here and continue and use our model in the next one. In this lecture, we're going to pick up where we left off in the last one and figure out a way to use the model that we built there and use it in Qt Quick. Here we are in the main CPP file of the project. We are going to include person model, create an instance of our person model, and expose it as a context property to Qt Quick. We are going to do that right in the middle here. And now we want to go to Qt Quick. To reduce on typing time, I have a QML file that is already prepared. So I'm going to put it in and try and explain it a little bit so that you understand what is happening here. Let's save it. It really is nothing special. We have a window object. It has a few properties here. And inside we have a column layout that contains the list view. Down we have a row layout that is going to contain a few buttons. We have the button to add a person. We have a button to remove the last person. And when you click on the button to add a person, we are going to show a dialog that I don't have defined yet. But the logic is that this dialog is going to allow the users to put in the names and the age for the person. And then we are going to add that person by calling the add person of the model that we have exposed in the main CPP file. I hope this makes sense. And inside the list view, it really is nothing special. We are just laying things out nicely. We have our model. We have a delegate that contains a row layout because we want our components to be laid out from left to right. We're going to have a text field. We're going to have a spin box, and we are going to have a rectangle containing the favorite color of the user. It's going to be 50 and 50 in width and height. It's going to read the color from the model. This is how you read it. It's going to contain a mouse area that you're going to click to select the color if you want to change the favorite color of the person. And this is an addition that we didn't have before, but it really is nothing special. You just open a dialog like this, and when it is accepted, you read the color that is inside, and we store it in the model. And when the dialog is rejected, we fall in here. You must know all of this from the basics of Qt Quick. Now I am going to add in my new file that we don't have here. You see we have the error here. The way I do that, I am going to go to the resource file here and click add new. I'm going to go to Qt, QML file, Qt Quick 2. I'm going to call it input dialog. Exactly like we see here, input dialog. I'm going to click next, next again, and finish. I'm going to have my file here. And again, I have this prepared before to save on time. I am going to take everything out and put in my file here and save it. I hope this really doesn't confuse you. This is a normal dialog. It contains a few things inside. Because we want the user to be able to type in the name, we have a text field for the name, and we have a spin box for the age, and we expose these things to be readable from the outside as property aliases here. Okay, we expose the names property, we expose the age property, and whenever we manipulate this, we are going to be manipulating data in here. I hope this makes sense. And we capture when it is accepted or if it is rejected. And we want to know when it is accepted from the outside. That's why we are using this signal here. And whenever the dialog is accepted, we are emitting this signal that is going to be used from the outside. And it is being used in main QML when we say on input dialog accepted. Control save. We are going to save this file. I don't know why Qt Creator is not picking this up because we have this already in. Let's clean everything. and run QMake. This is probably going to make this available now, and it isn't doing that. But right now, I think we can run our application and see our model displayed in here. And you see that we are using QQML context and we haven't included it. Let's do that, QQML context. Let's try to run again. Okay, you see we have our model here. We have in the data we wanted. If we go back in the person model constructor, we're going to see the data here. The first one is Jamie Lannister. The last one is Newt Vikran. And we have the data that we want. We can add person. And when we click, it wants the names of the person. So we're going to put in Daniel Gray. We can put in the age we want and hit OK. And you see that we have the person here. We can also change the color. Let's try to change the color of the first element here. Let's make it yellowish. Hit OK. And nothing is working in here. Why is the color not changing? Let's close the application and go back to our model and look at the setData method, because this is the method that is called when we try to change something in the model. And let's check it to see. Remember that to pass the changes back to the QTQuick side, we have to emit this signal. And let's see that there is something wrong here. Why is this here? Let's Control A, Control I to align it. And if we check, we're going to see that we put this if statement inside the switch. This is our problem here. Let's remove it and check the bounds of the switch and go outside the switch statement and put in our thing here. And I think that was the problem, because this is supposed to happen after the switch where we set everything and where we set this flag here to know if something has actually changed. And then we are emitting the signal here. I am sorry for that. If this confused you somehow, let's run the application again. And I hope for now it is going to work. Let's try to change the color. Let's make it blue color this time, sky blue. And you see the color here. And as we add things, we should be changing the model as we should have been doing all along. Let's change the name to Daniel Gray. And they say that we edited and finished. And this is the text coming from QML here. Let's go there, go to the text field. When we edit and finish, we are putting this here, but we are writing the text back to the model. If you don't believe that we are writing this to the model, you can come in here, the model, put in a debug statement. Let's include qdebug. And go down here where we change things. And it is saying we are returning without this is basically saying this method returns a variant, but there is a possibility of this function not returning at all, because if all these if tests fail, we are not going to fall in here and we are not going to return. So we should copy this and put it to the bottom here, and we should be fine by now. Let's build again. This warning should go away, and it does. We want to come here where we set the data and put in a debug statement saying that we changed what we are changing. We are going to say qdebug here, changing names for, let's put in the name that we have in the list. We're going to say person names. We are going to say the same thing here for the color. Changing color for this person here and changing age for this person here. Let's run again. And you are going to see that the methods from our model are actually being called when we change something. Let's change the name for Jamie Lannister and say Daniel. If we click, you see changing names for Jamie Lannister. We change the age, changing age. We change the color. It doesn't say if we are changing the color yet, but when we hit OK, changing color for that person here. You see that the setData method is indeed being called when we change something from Qt Quick. And this is really all there is to using a C++ model in Qt Quick. There are a lot of moving parts, but the bulk of it is really providing these methods here and adding in the methods that you need to try and make it as usable as possible. I don't think we actually tried removing an item, so let's go to the end here. And if we hit remove last, you see that we are removing the items and we can add new items again. Let's say 25 for the age for this person here. Okay, you see the new person, they are 25, and we can change the color to red if we wish so. This is really all for this lecture. In the next one, we're going to try and decouple the data that we store in here and store it in a separate class, because it is not good design to mix the storage of data with the logic for your model. I'll see you in the next lecture. In this lecture, we're going to try and extract our list of persons into a separate class that is going to only care about the data that we store, and it's not going to be concerned with the details of the model. So why do we want to do this? This is called design. You don't want to mix things that don't really belong together. This is going to improve reusability. For example, if the data that we are using is coming from a file, if later we want to use a model that uses data coming from the internet or coming from a database, all we have to do is change the data source and we don't need to change the model. This is good design, and I wanted to show you how you would do that and how it's going to fit in what we have designed so far. Right now, we're going to go to Qt Creator and show you how you can do this. Here we are in Qt Creator. We're going to create our project. It's going to be a new Qt Quick application. We're going to call it external data source. It's going to be stored in a given location on the drive. Choose the Qt version you have installed. Choose the kit you want to use for the project, and we finish. We are going to be improving on the project from the last lecture, so we are going to copy everything from there and start where we left. We're going to go to that project. You should open it. If you don't have it already opened, click on main, show in Explorer. We copy everything we have in there. Copy. Close the project. Let's collapse this again. Open our main CPP. Go where it is stored. We want to change everything in there. Override main, close this, and reload everything. And you see that our new file is here. We want to add the new existing files that we included in a minute. Person model. We have them here. And we want to add the new QML file that is going to contain our dialog. Add existing files, input dialog. This is the QML file we want, and it should be available now. Let's clean the project. Clean, run QMake, and run the project to see what we have. And we should have the list we had in the last lecture. Here we are. The first thing we want to do is to add in the data source class. So let's do that. Add new C++ class. It's going to be called data source. It's going to inherit QObject. Finish. We want to take all the data storage capabilities from this model here. So we are going to start here, control copy this, and I want to comment it out. Go back to data source, put in a private section like this, and paste in the list we had. We want to include the person class. go back to the model shouldn't have these methods in here because this is the job of the data source of adding data to the list that it has. We're going to copy all this, comment it out, go back to data source, and put in these public methods. We should implement them. Refactor, add to CPP, refactor, add to CPP, do the same here, and do the same for the last method here. The next thing to do is to go to the implementation of the model and move the implementation of these methods to the data source. Let's go back to person model and see the method that adds a new person to the list. Add person here. We can copy it and comment it out in here. This is how I do things incrementally so that I don't forget. And if I make a stupid mistake, I have something to fall back to. Let's go back to data source and add in the add person method. And notice that these methods are not available here. So what we're going to do is to comment these things out. And we are going to put in a bunch of signals that we are going to emit from here. And they're going to be received in the person model here. And it is the person model that is going to call begin insert rows and end insert rows on our behalf. I know this might not make sense yet. You're going to see how this works in a minute. Let's continue on our tour to remove a few things here. Let's copy this and comment this out for this method. And go back to our data source and put it in here. Go back to the model. We also copy this method, comment this out, and go back to our data source and put it in here. We repeat the same steps. Remove person at a given index. We copy this. We comment the method out. Go back to data source. Put it in here and comment these things out to remind us that we need to emit these signals. Let's go back to the model and see that we have something left. Yes, we do. We copy this and comment out the method, and we can go back to our data source. It seems we goofed up here. I am going to pause the video and move the code. I don't want to waste your time on this. Okay, I am done. I moved the methods. This is the first one, the second one, the third one, number 4. Let's go back to person model and copy the last line. Copy that. Go back to data source. And we should be done here. The next thing I want to do is to provide these signals that we should emit here. We are going to need a signal to emit before we add something to the model. We are going to need a signal to call when we finish adding to the model, and the signal when we begin to remove from the model and when we finish removing from the model. I am going to go back to the header, and you notice we have a signals section. I am going to put in a few signals that I have prepared. This is going to be called when we are about to add something to the model. This is going to be called when we finish adding something to the model. This is going to be called when we are about to move an item at a given index. And this is going to be called when we have finished removing the item from the model. Let's go back to the CPP file and actually emit this signal. So when we want to add to the model, we are going to emit. So when we are about to add to the model, we are going to say pre-person added and say post-person added after we finish. Here we should say pre-person removed and pass in the index, which should be the index here. And we're going to say post-person removed. And this is the signal that we are emitting here. And I notice we forgot the emit keywords, and this is a big mistake. Don't be like me, so put it here. Emit the signal, emit the signal, emit the signal. This is taken care of. We may also need to get a specific list of persons to use in our model. So we're going to provide a method to do that. Let's put it here. It's going to return a list of persons, just like this. Put it here, call it data items. I am going to implement it in the CPP file. If I go there, I should have it somewhere. Let's search for that. I can't find it. Data items. No, it's not implemented. Let's go back to the header and see what we exactly did. Add definition in CPP file, and we have it here, and it is going to return persons, just like this. Now we should be done with our data source, and it is taking care of the heavy lifting of interacting with this list of hours here. Let's close this. We can go back to the model, include our data source, and put in a data source field here, which is going to replace this list of persons. So we're going to say data source pointer. We want to provide a data source as a property so that you can set it from QML if you need that. Q property. The type is going to be data source pointer. It's going to say data source. And we are going to have our getter here, our setter here, and the notify method. We want to implement all these methods. So Qt Creator is going to help us here. We have set data source that we want to remove and take to the CPP file. We have data source that we want to take to the CPP file as well. Let's do that. We want to clean this up a little bit. This shouldn't be a slot. Let's make it a public method somewhere here. This will do. Control A, Control I to align. Now that we have our data source, we want to add a bool value here that says signal connected. And it is going to track whether or not we have connected to the signals that are coming from the data source here, the signals that we have here, because when we happen to change the data source, we're going to need to disconnect from these signals. I know this might not make sense yet, but you're going to understand in a minute when we change the set data source method to make it work a little bit better. We want to comment all this out because we're going to take it out in a minute. The first thing I want you to see here is that before you do any change on the model, for example, here, we are changing the underlying data structure in the model, and we need to let the model know that we are about to do that. There are two methods that we are going to use here. We are going to call begin reset model and end reset model when we are done with our changes. You can check these methods in the documentation if you want to read more about them, but they basically let the model know that its data is about to change, and it does whatever it needs to prepare for that. If we happen to have had a data source before, we want to disconnect the signals from the data source to the slots of the model here. So we want to say fm data source, and signal is connected, which is the bool value we defined in the header file. Let's actually put an m before so that we can recognize that it is a member variable. This is better. Signal connected. We want to say m data source disconnect and pass in this pointer. And what we are saying is disconnecting any signal from the data source to the slots that we had connected to in this object here. And you're going to see these slots. They are going to be Lambda functions that are defined in here. If you remember in the data source, let's go there. Before we add the person, we need to call begin insert rows. And when we are done adding a person, we need to call end insert rows. But we can't call these methods here because they should be called on a model. So what we're going to do, we emit these signals, and these signals are going to be captured in our model, and it is the model that is going to call these methods on our behalf. I hope this makes sense. So what we're going to do in here, we're going to say connect m data source, pound symbol, data source, person added, because this is our signal. We want to capture the signal in this object here, and we are going to use a lambda function that is going to capture everything in the context. It's going to have nothing in the parameter list, and we are going to put our body here. Inside here, we're going to capture the index because we're going to need it when we call the begin insert rows here. This is the index we're going to need. To capture it, we're going to say const int index equals, and we are going to capture that from the data items method of the data source. The way we're going to do that, we're going to say m data source data items and size. This is going to be our index, and after we have this, we can actually call this method here. We can copy it and put it in here. And now you see the benefit of not deleting these things, because they guide you through the process of doing these things. It is very easy to forget these methods. Even if you remember it is begin insert rows, you can mess the capitalizations and things like that. Now that you have this, we want to do the other connections to all the signals that we had. I am going to copy this one because they are mostly going to be the same. The only thing that we are changing here is the signal. So we're going to say post person added. This is the signal we want here. Let's go see in data source what we do. After that, we're going to and insert rows. So let's copy that, go back in the person model and call that method right here. It turns out we don't need this index, so we can get rid of it. We want to copy this again. We are going to do pre-item removed. Remember, this method takes an index of the item that we want to remove. Let's look at this again. This is the index we need to pass in here. So we're going to say pre-person removed, and we're going to pass a parameter in the parameter list for the lambda function called index. What is called in there? We call begin remove rows, and we pass in this index. Let's do that. Begin remove rows. And again, we don't need to pass in this index here. We want to copy this for the last time. Connect post person removed. We don't need this index here, I guess. Let's go back to data source to cheat a little bit. It says and remove rows. We copy that and we put that in here. Begin remove rows. And we are done connecting the signals from the data source to the slots inside the model here. And what this is really doing, I repeat this because it might be confusing to some of you. We were supposed to call these methods when we add the person here, but we can't because this object doesn't have access to the methods of the model. And these methods happen to belong to the model. So what we are doing, we are delegating the work of calling these methods to the model by emitting the signal. And in the model, we are connecting the signals of the data source to the slots we have in here. And these happen to be our lambda functions in here. I hope this makes sense. After we do our connections, we're going to say m signals connected and set this to true. And by now you should see the importance of this. We don't want to disconnect if we haven't connected before. This is going to be the effect of this. I don't think we initialize this value. We should go to the constructor and initialize this to false. We're going to say m signals connected and make it false. Okay, now we have everything in place, but I just noticed that we forgot to do something. This method set data source here is about setting the data source, but we are not setting any data source. So we should come in here, and after we disconnect, if we need to, we're going to say m data source equals the new data source that we pass in here. So we're going to say data source. The next thing we need to do is to investigate the methods of the model to see that there isn't anything we should change. And notice here, we don't have access to M persons anymore. What we should do is M data source, data items, size. That's what we want to return here. Let's go in here and see what we can do. And we don't have access to M persons anymore. So it is going to be the same here. Let's copy this and put that in here. This is going to work fine. We don't have access to M persons anymore. So what we're going to do is replace M persons here with the list that is returned from the data source. Let's copy this and actually try this. And I hope it's going to work, because this is going to return a list, and we can read from the list like this. Or instead of using this crazy syntax here, we can just do a NAT and pass in index row like this. This is more readable. I like it better. And we are going to have a person pointer to work with here. We should do the same for the other methods. We're going to copy this and put it in here. This is going to take care of our troubles here. We are going to change the person here. Flag if something changes. This should be fine. The flags, nothing we should change. And we are looking fine for the moment. Okay, now we can go to where we create instances of the model. It must be in the main function here. All we might need to do now is to create a new data source instance. We're going to include the data source. We can create an instance of data source. Let's call this DS and say new data source, and pass in the parent, which is going to be the model. And we're going to say M model set data source and pass in DS here. If we go in Qt Quick, we are trying to read something on my model here. If you go in there, you're going to see we are trying to call functions on the model when we add people in the model. So we're going to comment these out because they're not going to work. We're going to fix them in a minute. But for now, all we want to do is to provide this model to be displayed in this list view that we have right here. Let's try and build our code because we changed a lot of things. If we have any errors, the compiler is going to capture that for us. So we can't add people in the model anymore because we don't have these methods in here. So we should move this back to the data source. Let's put that in the constructor here. And you're going to see that we have these methods. Let's build again. It looks like the build is successful. We can run the application. And here we are. We are using a new model that is backed by a separate data source. Let's try to change something in here. Let's say Daniel. We hit enter. We say changing names for Jamie Lannister. So this is really great. Let's change the color and see that the changes are still there. And our model is communicating well with Qt Quick. This is really all we had to do in this lecture. And the bulk of it was really moving the data handling capabilities from the model to a helper class that is called data source, that is taking care of these things here, adding persons, removing persons, and it is notifying the model of any changes it's about to make or when it has finished doing the changes through these signals, and the model is responding to these signals by the connections that we did here. There really is nothing complicated about this. I know there is a lot of moving parts and some of you are going to be confused, but look at it a little bit, and if you happen to have a question, don't hesitate to ping me and I'm going to help you out however I can. Now we are done with this lecture, but we want to clean up all this mess that we left in here so that we have a clean project. It is done helping us keep things straight, and I think it is a good time to remove them. So let's do that. Let's go to the header and see if we have anything worth removing. Let's remove all this. We don't need this list anymore. Let's go up, go in our data source. This is clean. Go in the CPP of the data source. Let's remove these things. Let's remove this. Do we need this index? No, we don't. Let's remove it. We go down and do all the cleanup we need to do. And this looks clean enough for me. Okay, this is working now. But if you remember, the model doesn't have access to these methods anymore. So what we can do is also expose the data source as a context property. Let's go back to the main function and expose the data source just like this. We're going to say my data source is ds, which is our data source here. And all we need to do now is to come to our main QML file and comment this and say my data source, and say my data source to add a new person to our model. And if we run the application now, we should be able to add people and remove people from our model from Qt Quick. Let's wait till the application runs. The app is here. You see we have a few people in. Remove last. You see the last person is gone. Add person. We have a window here. We can say Daniel. They are 20 years old. Okay, you see Daniel here, and we can change the color and play with the object however we want. This is all for this lecture. In the next one, we're going to see how we can add object list capabilities to our model here and make it completely instantiable in QML. I'll see you in the next lecture. In this lecture, we're going to see how we can enable our model to use list properties. List properties allow you to do something like this. You can define your model completely in QML like this, and you can add a bunch of persons inside. And we are using default properties here because we don't need to specify the list property that is taking this list of persons. To build this feature, we need to do a few things. We need to expose our list of persons as a QML list property, and we do it like this by putting these lines in our model class. If we want default properties, we also have to put in the class info macro like this, specify the method that is going to be the default property, and we need to specify a bunch of methods that the QML engine is going to call to manipulate our list. You know this already. We have the append method, the count method, the at method, and the clear method. Once you have your model ready, you have to expose it to QML to be instantiable, and we use the QML register type method that we have seen also before. Okay, this is our goal for this lecture, to turn our model into something that we can use like this. We're going to go to Qt Creator and do that. Here we are in Qt Creator. We're going to create a new project because we don't want to override what we did in the last one. It's going to be easier for you to keep track of things. We're going to call it model list properties demo. Save it in a location on our drive. Choose the Qt version and choose the kit we want to use for this project. And we're going to finish. We want to load the project from the last lecture completely because we are going to build on top of it. Let's open it. You should open it if you don't have it open already. Click on main. Choose show in Explorer to go where the project is stored. We copy everything in here. Control C to copy. Close this and close the project. We open our source folder. Show in Explorer. And we are going to paste in everything and override main CPP and main QML with the new files that we put in here. Let's close this. Qt Creator is going to go crazy, saying that something has changed. We want to reload everything. We want to add the existing files to the project. We are going to add, not the main, but all the classes that we imported. Main QML and main CPP are already in the project here, so we don't need to import them. Here we are. We also need to add the QML file that we don't have in this project. We click on the QRC file here, choose add existing files. We add the QML file, the dialog, to let the user type in stuff. And we should be done by now. Let's build and run. And we have our app here, and we have a bunch of items inside. Each item is representing a person object backed by the class here. What we want is to add list property capabilities to our model. And you know what we need to do first? We need to import QML list property. We want to add in another Q property. Let's do that. And it's going to wrap around persons. We're going to say persons and hit enter. We don't need a write method, so we're going to take it out. We're only going to provide a getter and a notify signal. We want Qt Creator to help us generate the methods. Let's do that. And the methods are going to be put in here. Persons changed and persons. We want to move this method to the CPP file. And we are going to modify it to return a QML list property that wraps around the method that are going to manipulate the list we have in the data source. I have this prepared, so I am going to put it in here to save some time. Control A, Control I to align. We need to provide these methods, so I am going to go to the header file and put them in the private section of my class. Control A, Control I to align. We have the 4 methods for appending, getting the count, getting an instance of the person at a given index, and clearing the list. Let's implement the method. Refactor add definition in CPP. Refactor add definition in CPP. Refactor again, add definition in CPP. And do the last one, clear persons, add definition in CPP. To work with the parameters of these methods, we want to give them names. So we're going to put list here. Person is going to be person. This is also going to be list. List again. And the integer is going to be the index. And this is going to be the list again. For the append method, we want to reinterpret cast person model pointer. What we want to cast is list data. We want to get the data source and add person because we have a method to do that exactly. Notice that we have an override that takes a pointer to person, and we can pass this in directly. This is taken care of. We want to get the count. We can get the count directly by querying data items from the data source and getting the count of that. So we are going to say this data source. We copy that, put this in here. We're going to say data items. Why isn't this working? We forgot the R here, and that's why this is not working. Let's do data items and take the count of that. This is going to be the count we need in here. But we need to get a person at a given index. We put this in here and we say at a given index, and we pass in the index. This is going to return a person. If you hover over it, it's going to return the type that the list here contains, and it happens to be person. We also want to clear the persons, so we're going to provide this method in the data source and call it from here. Let's go to the data source. Now that I think about it, I think we should provide all the methods that do these things in here. Control A, Control I to align. The count is also going to come from the data source, and this is going to be more maintainable. So I am going to provide these methods, and I am going to call them back from our model. Let's do this. Add the definition in CPP. Add definition in CPP. Person count is going to be what we expect. Return persons count. person at a given index, return persons index. And clear persons is going to say persons clear. I think we have a clear method on the list, and this should be fine. So we should go back to our model and change a few things. The append method is not going to change, but the count method is going to change. We're going to call the count method on the data source. So we're going to say person count, which we just provided in a minute. The person at a given index is also going to change. We want to use the data source and say person at a given index. This is going to be better. Clear persons is also going to call a method on the data source. Let's copy this, put this in place, and say clear persons. Now our methods are working as expected, and our model should be now able to work with list properties. Okay, the last thing we want to do, we don't want to set the data source externally like we did in main here, because our model is going to be completely usable from Qt Quick. So we want to go to the constructor of our model and set a data source in here. We're going to say set data source and say new data source and pass in a parent of this. The model is going to be responsible for clearing this memory when it dies. This should be all we need to do in here. Let's go back to main CPP. We don't need to expose this as a context property anymore. What we want to do is to register the model as a type that can be instantiated in QML. We're also going to expose the person because we are going to be putting persons inside the person model. We are also going to get rid of this instantiating of the model and immediately say QML register type, the person, and QML register type, the person model. Control A, Control I to align. The rest is really everything you know. These are going to be in the module called com-blycon models, and we are going to instantiate them in QML using the names here. Now we can go back to Qt Quick, take out the model here, and say model ID. And we want to go to the top and include our model module. We're going to say com-blycon models and say 1.0. This is the version we presented in main, if I remember correctly. We are correct. And down here, I can say person model. You see that it is recognized now. And inside, I can start putting a bunch of persons. But if you look in the model, I didn't enable my model to use default properties. So all I can do in here is say persons and pass in a list of persons, or I should say an array in JavaScript. And I can pass in a bunch of persons like this. Control A, Control I to align. I am basically creating person objects and specifying the roles for the name, favorite color, and age. And to know that this is working, I am going to go back to the data source, take out my initializer, data. I also want to go to person and say that we are creating a person object in the constructor. So I am going to go in here. We want to say qdebug. The names are stored in mnames in here. This should work fine, but we also should do the same in here, just in case. And in this constructor, we should also initialize everything. Let's check this out. Initialize these things to some default values in this constructor because I don't like to have data that is uninitialized. QObject is already taken care of, so we should do that. Mnames, we're going to say none. Favorite color, we're going to say none. And the age is going to be 0 in here. We should build and see that we have no boo-boos in the code that we have done so far. And if we click on this arrow, it It's going to tell us that we are trying to do this error comes when you return const here, because the QML list property is going to be modifiable. You don't want this method to return const. The person's method, let's find it. And it is here, it is returning const. Let's take the const keyword out. Build again. We have a few warnings here. I hate these warnings. So I did something stupid here. I didn't return. See why it is a good idea to check your warnings. And I am not returning again. This is very stupid. And here I don't need to return anything. Let's build again. Now we can run. What is wrong? Let's look at this. And M model ID is not defined because we didn't provide an ID for this model here. Sorry for these errors you are seeing here, but it is all part of learning. So let's do this. ID, M model ID. Let's run again. Hopefully this time it's going to work. And it is, we are seeing our data here. If you look inside, we have Daniel Gakwaya. His favorite color is yellow. We have Guiza Luna. Her favorite color is blue. And we have Steve Barker, who likes yellow green. And our data is coming completely from QML like this. Our list properties are working. The remaining thing is to enable this to work with default properties. And all you need to do is a one-liner. Let's go back to our model. Go right below the Q property for the QML list property. And all we need to do is put in this macro here, saying that persons, which is this method here, is our default property. Now we can go back to main QML, comment out our setting here, and we can specify our persons directly like this, Control A, Control I to align, without specifying that they are belonging to the persons property here. You can directly put in persons like this. If we run, we are going to see the same result, but I think this is much cleaner and more usable by QML developers. So your model, usable like this, is going to boost the readability of your code. And we can still update the properties as we did before. You see the color changes. When you put in something like this, the model is going to add these things to your data using the methods that you provided. In this case, it is using append person to add people that it sees here to your data source. Okay, the last thing we want to do is to go down here and find ways we can update this to be able to add new data sets to the model and remove the last item. As we see here, we are still using my data source and we should use the model. To be able to do that, we're going to go to the model and provide the methods that are going to add items and remove items from the model. This is going to be very easy. We're going to put the methods here and you see it really is nothing complicated. They are Q-invocable methods. And we add person to the model and we remove the last item. We need to implement this method, so let's do that. Refactor add definition in CPP and do the same for the remove last item. We have the methods here in CPP. The add person method is going to create a person instance and add that to the data source. We're going to say m data source add person and pass in person here. The remove method is going to say m data source. It's going to call remove person. And we're going to say m data source person count and -1 to get the last item. I think this is going to work just fine. Now we can go back to QML and update our code to use these two methods that we put in here. We can go to QML and here we're going to find the ID of our model. The model is M model ID. We can copy it go down a little bit and find our calls to the model. We put in model ID here and we put in model ID here. And let's double check to make sure that these are the names that we have in the model. This is add person. The other one is remove last item. Let's copy it just to be sure. Let's go back to QML and this should be fine. If you look up here, you see that we also need a favorite color and we are not passing it in our QML here. So let's pass in a yellow green by default. This is going to work, and put it in the middle like this here. I think we can run the application and see what we get. Okay, we have the app here. Let's add person. Let's say Daniel Gray. Let's say they are 20 years old or 21. And you see that we have the person added here, and we can edit the color as we want. We can also remove the last person. You see that they are gone, and add the person again. We can say Daniel Matson, and they are 25. Okay, and you see that we have the person here. Our app is working exactly the way we want. This is all for this lecture, and I would like to congratulate you on building a model that is completely usable in Qt Quick like this. This is the last lecture of the chapter. In the next lecture, we're going to review the content of the chapter and compare some of the techniques we saw and try and see how some compare to the others. I'll see you in the next lecture. Congratulations on making it to the last lecture of the chapter. This is one of the toughest chapters of the course. You learned different ways you can expose your data as a model for use for Qt Quick. We started by showing you how you can use simple string lists to pass some simple data as a model to Qt Quick. We then moved on and showed you how you can expose a list of objects. We made the model editable and showed you different approaches to editing your data. You saw how you can reset the model data using context properties and how you can propagate the changes to your properties to QML using QProperties mechanism. We moved on and showed you a way you can implement your own model completely from C++ and make it available to Qt Quick. We showed you how you can decouple the data from the model and have a separate class to manipulate your data. And we closed the chapter by showing you how you can enable your model to use list properties, making it a model that is completely usable in Qt Quick. Implementing your model completely in C++ using the model classes is the best way to go. If you have huge data sets that change frequently, you shouldn't really use the simple way we saw of using string list and object list, because these have a performance cost involved when you change the data. But when you happen to have simple data sets that you simply want to pass to your list view, this can come in quite handy because implementing your own model is also complicated and you have huge code bases to maintain. I hope this chapter was fun and entertaining to you. In the next lecture, we're going to do a demo and practice what we learned to update our REST API client to use a completely custom model from C++ as we saw in this chapter. I'll see you there. Welcome to this new chapter. This chapter is about practice. We are going to practice on building our own custom C++ model and use it in QML. Here we have a REST API client that we have built in a previous course, but you don't need to watch that course to be able to work with us. If you have the knowledge, I am going to give you the source code, and in a moment we're going to go through the source code, show you how we implemented that thing, and lay the foundation for what we are going to do in this chapter. We basically have a REST API client that is downloading data from the internet in C++, and we have figured out a way to expose that data to be displayed in a list view in QML. What we're going to do in this chapter is use a C++ custom model to expose that data so that we can take advantage of the features that the C++ models offer to us. Let's go to Qt Creator and show you the project that we have so far. Okay, here we are in Qt Creator. This is the version 1 of the REST API client that we had. I'm going to run it first and show you how it works. Okay, you see it is running here. You can specify the number of jokes that you want to get from the internet. Let's say we want to get 5 jokes. Hit fetch, and you are going to get 5 jokes. You can get 2 more jokes if you want. Specify 2, hit fetch, and you see that we get 2 more jokes. Okay, this is the workings of the application. If you look at it, let's go in main, you see that we have an app wrapper. If we open this app wrapper class, let's go to the header, you see that it has a few invocable methods and it has some network capabilities to download data from the internet. If you go to QML, let's go there. You see that when we click on the fetch button, we are calling a method on the wrapper object that we exposed, and it is this app wrapper. Let's go and find the fetch posts method. It is here. You see that we are specifying the API and firing the request to download data from the internet. When we get the data, we figured out a way to send the data to QT for display, and we do that in the data read finished method here. You see that we add the data to the jokes and we call the reset model method here. What this method does, it is really resetting the context properties. We want to change this. We don't want to use context properties because you already know that context properties are really costly if your model happens to be changing frequently. We want to use the C++ model that we built in the last chapter. Okay, so this is the challenge. You have to take this application and refactor it to use the C++ model. And at the end, we are going to have the same functionalities as we do here, but the C++ backend is going to be much more efficient performance-wise. Okay, this is our goal here. The other thing I want you to know is that the source code is available. You can download it. It's going to be attached to this lecture. So when we get in the next lecture and open this project to start working on it, you're going to download the source code that is attached to this lecture that you are watching now. Okay, so what we're going to do, we're going to build a data source that is going to store the data. We're going to put together the model, and we're going to put everything together so that our application works exactly the same way it was working before. I want to stress that this chapter is just a way to give you more chance to practice on working with models because they really are important. So if you can do it, try to craft this thing yourself. You already have the knowledge that you need to do that from the last chapter. Try to do this on your own, and when you're done, you can check my solution. And if for any reason you can't do it on your own, do start in the next lecture, and let's go together as we refactor the code to use the C++ custom models. So we are going to stop here now and get to work in the next lecture. I'll see you there. In this lecture, we're going to go on and put together the data source for the version 2 of our REST API client. We're going to go to Qt Creator and do that. Here we are in Qt Creator. We're going to create our project. It's going to be a Qt Quick application as usual. We're going to call it REST API Client V2 Demo. Save it in a location on our drive. Choose the Qt version we have. Choose the kit we want to use. It is the desktop one in this case, and we finish. We are going to copy over the files from the REST API client version 1 and update on top of it. I have it opened. If you don't have it opened, you should go to the chapter where we have this project and you can open it. And I am going to attach it to the current project so that you can find it immediately if you find it annoying or hard to go back there. Anyway, you're going to have the project here. Open it, go where it is stored, show in Explorer. I want to copy everything, the app wrapper source files and header files, main CPP and main QML. I copy those. I close this, I don't need it anymore. Find the main CPP of the current project, show in Explorer, and paste in everything. We're going to override main QML and main CPP. We want to close this. Qt Creator is going to complain that something has changed. It's going to ask us to reload everything. We're going to say yes to all. We want that. We want to add the files that we loaded to the current project. We're going to say add existing files, and we're going to find app wrapper, header, and CPP, and add that to the project. It is here in the project now. Let's build and see what we get. We shouldn't get any error because it is pretty basic right now. Let's run. And we have our starting point here. Let's say that we want to fetch 5 jokes. We hit fetch and we have 5 jokes from the API endpoint that we are using in here. Now we want to create the data source class because that's the topic of the lecture here. We want to add new CPP class. We call it data source. It's going to inherit Q object. Finish. Let's go to the header. The first thing I want to do is to move all the networking code from app wrapper and move that to the data source class. So we're going to copy all the network related classes and include them in data source. Let's go to app wrapper again and find anything that relates to network, and we're going to move that to the data source. Let's go to the private section here and copy over all these objects, put them in data source. Here we are, Control A, Control I to align. Let's go back again and see what we can get. We can actually get all these methods here. The list of jokes, the methods to manipulate the list, they should move back to data source. So let's copy those, come back to data source and put them here. Control A, Control I to align. This should be const. Let's go back. We should take the signals here because these are used when downloading stuff. We should put them in the slots section. Let's align this and put them down here. Let's check again and see that there is something we can move over to data source. By the way, we should comment out these things that we moved back because we don't need them here and they have a chance of confusing us later. We are going to delete them later when we have everything running. This is my workflow. I think we have everything we need. Let's go back and implement all these methods. We're going to do fetch posts, refactor, add definition in CPP. We want to do remove last. Same thing. This is not implemented also, so let's do that. Let's go back and we need to also implement the slots here. They are going to respond to our network requests. I think this is all. We should go back to the CPP file and try implementing these methods. Let's go back to app wrapper CPP and see what we can copy over. The download happens here, so let's do that. We copy the code, bring it to data source and put it in here and see what we can put in again. You see everything is working the same way except that these signals are no longer in app wrapper. They are coming from the data source, so we should say data source here and copy this and put that here. This should be taken care of. Let's see that we don't need to do any initialization. You see that we are initializing these things. We should also do that. Let's copy this over, go to data source and do the initialization of our data fields. Net manager, net reply, and data buffer. And we start our download of the APIs like this. Let's go back to app wrapper and copy over another method. Let's copy over, remove last, copy, data source, remove last. It really is doing nothing special. It is just removing the last item from the jokes, and we don't need this method because we don't want to reset the model. We're going to do whatever we need to do to get this to work later. Right now, we just want to lay the foundation down. Let's go back. We don't need to initialize anything right now, but we can do data read. Let's copy that, put that in here, and we can go back to app wrapper and do data read finished. We can do that. Let's check the bounds of this method. Yes, it is here. Let's copy all this move to data source and put in the code and see that we can update some things. Okay, we have all the code in here, and this is going to return the list of jokes. Let's find that. It is returning mjokes, data source, and return mjokes. Okay, now we have all the code in here. Now, we don't want to model this as a string list. We want to model this as a list of jokes, and joke is another object that we are going to define in a minute. So we're going to say QList joke pointer and say mjokes, and we are going to comment this out. And we should create this class so that we aren't doing things in the air. Let's do that. We're going to create a new class. We are going to call it joke. It's going to inherit Q object, hit next, and we have the class here. The class is going to have a Q property. It's going to be a Q string, and it's going to say joke. And the system is going to generate the getter and setter methods and the signal here that is going to be emitted whenever something changes about this joke here. We want to generate the methods for this to work, and the methods are here. We want to put in a private section and move the data field in the private section. Move the methods to CPP, the implementations of the methods. Let's move this to CPP, our getter, and do some cleanup to clean up this. And I don't want to expose this as a slot. You probably know by now that I don't like that, but it is a matter of choice. You can put it wherever you want. It is going to work. And we have our class here, the joke class. We can now go back to data source and include that. We also want to replace this method jokes with a more descriptive method that says data items. And let's find it down here. Let's delete this actually, and let Qt Creator help us in implementing this. And here we are. And we are going to return mjokes, which is the list we are working on. Let's go up again. Since this is a data source, it is going to manipulate the model, and we need to provide the signals that are going to let the model know that we are about to do something or that we just finished doing something. You must remember this from the last chapter. So what I'm going to do, I am going to put in the signals, Control A, Control I. We do pre-item added, that is called whenever we are about to add something to the model. Post-item added is called whenever we finish adding something to the model, and the logic is the same for removing something in the model. If we go down in CPP, let's see that we didn't have something like that. We are going to need to do that whenever we add and remove something from the model. Right now, this method is saying fetch posts, and we are not fetching posts, we are fetching jokes. So I am going to rename it a little bit, refactor, rename symbol under cursor, and we are going to call it fetch jokes to make it more descriptive. And this is going to replace the name here throughout the entire project. We also want to rename this. Let's call it remove last joke and replace, and it is replaced throughout the entire project. Next, I want to add in a few methods that we are going to use to manipulate the list. Let's put in some spaces here so that you see the methods. It is really a bunch of overrides for adding a joke. We have one that takes a pointer. We have one that doesn't take anything. We have another one that takes a string in the parameter. And we have one to remove a joke at a given index in the model. We want to implement this. Let's do that. Refactor, add definition in CPP. Refactor. Refactor and do the same. Refactor and do the same. And we should now try and implement these methods. Before we add something to the model, we should emit pre-item added and emit post item added whenever we finish adding something to the model. And now what we should do is jokes append the joke that we have in the parameter. And this will do. And all these overrides, add joke here and add joke here, are going to call this one. We are just going to construct an object inside here and add that to the list using this method. And this improves on reusability in our code, and the code is easier to maintain because we have to maintain the code to add the joke only in this method here. The method without any parameter is going to create a joke object and add that to the list. It's going to say add joke, and this is going to work fine. This one is also going to be almost the same. We're going to create a new object, but it is going to take this string here. So let's do that. Let's say joke param, and this should be fine. And we are giving these joke objects a parent of this data source, so that when the data source is destroyed, these objects are also destroyed and we're not going to leak memory. This is an added feature that comes with using Qt. Pretty cool, right? Now we want to remove joke, and before we modify the model in any way, we need to emit the signal to let the model know that we did something. We are going to emit pre-item removed, and this is going to take an index, so we're going to pass it in. And after we are done, we are going to emit post item removed, and this is going to be all we need to do. Now we can remove the item in the middle here by saying mjokes remove at, and remove the element at index. This is taken care of. Remove last joke is actually already implemented, so we don't really need to do anything in here. This is going to work exactly the same. We are checking to see that there is something in the jokes before we remove something. And this is going to remove the last item. If you don't believe me, you can click on F1 and see what this method does. It removes the last item from the list, okay, which is the same as remove at size of the list -1. So it is a convenience method that the Qt framework is giving us to ease our lives. Now we basically have all the methods we need for the data source. We have a bunch of methods that we can call to manipulate data in the model. And we are also going to expose the data source to the Qt Quick side so that we can manipulate this list here from Qt Quick. For example, the remove last button that we have from QML, which is this one, it is going to call this method in the data source to remove the last item. But we're not there yet. We're going to get there. This should be all we need to do to have our data source ready. We're going to stop here, and in the next lecture, we're going to put together a model that is going to use this data source. I'll see you in the next lecture. The last lecture left us with a data source that is hungry for a model to connect to. We're going to build that model in this lecture. Let's go to Qt Creator and do that. Okay, here we are back to our project. This is the data source that we had before. Now we are going to create the model. It's going to be a new class. Add a new C++ class and call it joke model. You can call it whatever you want. It is going to inherit Q object for now and finish. Let's go to the header. We want to include our parent model class, which is abstract list model. We also want to include our data source and modify the joke model to inherit the list model that we want to use here. We should also update the implementation because the parent has changed here. Let's go back to the header. We want to put in a Q property. The data type is going to be data source, and pointer, it is going to be called data source. We don't want the notify part of it. We just want the getter and the setter. Let's put in a private section and generate the methods. Refactor, put in the methods. We're going to have a data source getter, refactor, put in CPP. No, refactor, move to CPP. This is right now. Refactor, move to CPP. And we want to go to the header and clean this up. This shouldn't be a slot. Let's put this back here and remove the keywords for slots. Control A, Control I to align. We have our data source now, which is exposed as property. This being a model, there are a few requirements we need to fulfill for it to be usable, both in C++ and in Qt Quick. And we are going to put in a few methods in a minute, but these methods are going to need an enum. Let's define that enum. I want to define it first here. Let's call it model roles. Inside, we're going to say joke data role and make it equal to Qt user role +1. Now we want to put in the required overrides for this to work as a model. I'm going to paste them in here because I don't want to type all this. We have a row count method, a data method, a set data method, a flags method, and a role names method. Let's implement these one by one. Come back, data, refactor, CPP, set data, refactor, put in CPP, flags, put in CPP, and the last one is going to be role names and put in CPP. We want to start by the easy ones. We can start by the flags method here. We are going to check that the index is valid and return if it is not valid, saying that we have no flag to set here. And if it is valid, we're going to return Qt item is editable because we want this model here to be editable. For the role names, we're going to create a QHash object. It's going to take integers and Q byte arrays, and it's going to be called roles. And we're going to put in a piece of data. We're going to say roles. The key at joke data role is going to be equal to joke. This is what we are going to use in QML. And if you remember, this method helps you specify the roles for the objects that you want to store so that they are usable in QML. It is what we are doing here. Now we can return this QHash, return roles, and this is going to be taken care of as of now. Let's go to row count. It is also a pretty easy one to implement. We are going to return the number of items in our data source. So we are going to say m data source data items count. This is what we are going to return. And this is unused. It is a good idea to wrap it in a QUnused macro so that the compiler knows that we are not using that. Let's put in the required semicolon. We want to go to data here. Remember that this method is called whenever our list view or whatever view we set to use this model wants to fetch some data, and it passes in the index, which is the location of the item in the model, and the role for which it wants the data. The first thing we want to do is to check the bounds. We're going to say if index row is less than 0 or index row greater than the number of items that we have in the data source. Let's say greater than equal and say m data source data items count. If it is less than 0 or greater than this, we are going to know that we are going beyond the bounds, and we are going to return an empty Q variant. And the list view is not going to have anything to display. If we fall down here, it means that we are within the bounds where we are going to get some valid data. We are going to create a job pointer object. It's going to be coming from the data source. We are going to say m data source data items at index row. This is how we fetch the data item. And if the row that we pass in the parameter list here equals to joke data row, we are going to return the joke information inside this joke here. We are going to say return joke, which is the joke that is stored in this object here. Okay, this is the blueprint for our jokes. Let's go back to our model and keep working on it. If we don't fall in here, we should return something because this returns a Q variant. We are also going to return an empty Q variant, but we are most probably going to end up here. But this is safe programming because you really never know what is going to happen with your application. So we play it safe here. The setData method is also going to work pretty much the same. We start by getting the joke object at a given index, the index that we pass in here. So let's get that. And we are going to define our bool parameter saying that something changed. And we are going to set this to false by default. We are going to switch against the role. And for the case of joke data role, let's move this column here. It shouldn't be here. When we have a role of joke data role, we want to check to see that something actually changed before we change the data in the model. We are going to say if joke is different from the value that we have in our parameter toString. If they are different, we are going to set the data in the joke object that we have here. And remember that this is a pointer and we are directly modifying something that is in the list in our data source. So we can safely say joke, set joke, and pass in value toString. And after we do that, we say something changed, set this to true. And after we fall out of this switch statement, we're going to go down below it and say if something actually changed, we are going to emit a signal to let anybody who is interested in this model know that something changed. We are going to say emit data changed. The start index is going to be the one we have in the parameter list. The end index is also going to be the same. And we are going to create a Q vector of integers on the fly here and put in our role that we have in here. This is going to emit our signal. And after we do this, we can return true to say that everything is all right. And if we fall down here, something went wrong, something didn't change, and we should return false to say that this setData method didn't actually do anything to the model. This is what this means. The only thing that remains is to go down and look at the setDataSource method, and we need to make the connections to the signals that are coming from the data source. When we emit these signals, we want to respond to them in the model, and the best place to do that is when we set the data source. So let's come here. The first thing we need to do is to let the model know that we are about to reshuffle everything. Let's do that. We're going to do that by calling begin reset model. This is the method we want. And the last thing we want to do in this method is to call and reset model. We want to go back to the header file and actually put in a bool data field to store whether we have connected to the signals. You probably remember this from the last chapter. We're going to do bool signals connected. And we want to initialize this to false. And this is a correct syntax to initialize things in your classes in the header file. This is perfectly fine. You can also initialize in the CPP file like we did in the last lecture, but it's all the same. Down in setDataSource, we want to say if we actually have some data source, we're going to say mDataSource and signal connected. we want to disconnect the signals from the data source to the model here. And we do that like this. Down below, we want to do the connections again. We are going to say connect m data source, pound symbol m data source, pre item added. We're going to do this for this model here. And we are going to put in a lambda function to respond to that in here. Inside, we want to capture the index. We're going to say const int index equals m data source data items count. We're going to capture the count, which is going to act as our index where we want to add something new. And we are going to call begin insert rows. We want the root index, which is going to be Q model index here. And the starting index is going to be index. And the ending index is also going to be index. This takes care of notifying that we are about to add something to the model. I am going to copy this and adapt it to work with post item added. Let's change this to post item added. We don't need the index here, so we're going to take this out, and we are simply going to call and insert rows. You probably remember this from the last chapter. Let's copy this and do for when we are about to remove something. We're going to say pre item removed. This is also going to pass in an index where we want to remove the item, so we put that in the parameter list. And we are going to use that in the body here. We are simply going to call begin remove rows. We are going to pass in the root index just like this, and pass in the start index, which is index, and the end index, which is the index that we passed in here. We need to do the last one, which notifies that we finished removing something from the model. It's going to be post item removed. We're not going to need any of these things. We're just going to say and remove rows, and this is going to be fine. In case this is confusing you, these signals are coming from the data source, and they are being emitted whenever we try to modify the model, the data that the data source is wrapping around. Notice that when we add a joke, we emit pre-item added, and when we finish adding a joke, we emit post-item added. We are trying to connect to those signals and call the methods that notify that something changed in the model, because this is where we have access to these methods. We don't have access to these methods in the data source. So I hope this makes sense. This should be all to have our model working as it should. We're going to stop here because the lecture is getting pretty long. In the next lecture, we're going to find a way to put this all together and have this app running for the first time. I'll see you in the next lecture. In this lecture, we're going to put to work the data source and the model that we have built so far. Let's go to Qt Creator and do that. Okay, here is our project. We're not going to waste any time. Let's head to App Wrapper and see what we can cook up. Because if you remember, this is the class that is called in main to do our own initialization. And everything is really happening in the initialize method. If we follow it by clicking follow symbol and a cursor, we're going to fall there where we are loading everything. All we really need to do now is to expose our model and data source as context properties, and we are going to be able to use that in Qt Quick here. But before we do that, let's clean up App Wrapper first. Let's comment out the reset model method because we are also not going to need it. We can also comment it out in the header like this. I also think we have some junk in the implementation file. For example, we don't need these two methods, data read finished and data read, so we can safely comment those out. We don't need the methods to get the jokes because that's not the job of the app wrapper. We also don't need the method to remove last. It also turns out that we don't need to fetch posts. So we're going to get rid of all this, I'm sorry if this is confusing you, but I am leaving them here just in case I need to cheat a little bit on things I have in here. I also noticed that we need to remove this initializer list here. Let's comment this out. And we need to go to the header. We have our engine here, but we can also put in our model. We need to include the model. Let's start by the data source and include joke model. And we can go down here and create our model, say joke model, and come down here in the initialize method. We can actually take this out because we're really not going to need this. Next, we want to create our data source. We are going to say data source pointer. Let's call this ds and say new data source and give it a parent of this because the app wrapper is going to take care of cleaning up this memory. And we are going to set this data source to the model. So we are going to say mjoke model set data source, and it's going to take dsn as the data source. Now we can start exposing these things to be available in QML. The first thing we want to expose is the model. So we are going to say mEngine. Remember, we have the engine here. Set context property. It's going to be available as my model, and it's going to take in the address of the joke model. This will do. We also want to expose the data source because we're going to use it to manipulate the data. It's going to be available as my data source, and it is going to take in ds because it is available as a pointer to us right now. Now that we have this, we can actually go to QML and figure out a way to use this. One thing I want to do, I want to capture this model here and go to QML and find where we are assigning the model to the list view. It is here. I am going to make sure it is that model. And let's go down and see where we manipulate the list. We are going to fetch posts. Here we were using the wrapper, but the wrapper is no longer capable of fetching posts for us. This is the capability of the data source now. So we should use the data source to fetch jokes. Let's go to app wrapper, capture a reference to the data source, go back to QML and put that in here. And this is going to work for us right now. Let's go down and see how to remove the last post. We also have the method here. Let's go back to data source and find remove last joke, follow symbol under cursor to find it. And it is here. And if you look, we are directly removing the last joke without emitting the signal. And we should really find a way to reuse this method because the features are almost the same. So there's no need to duplicate the functionality in two functions. So what I'm going to do, I'm going to comment this out. I'm going to remove it later. And I am going to remove the item at the last index in the jokes list here. What I'm going to say, I am going to say remove joke. We are going to reuse this method and say mjokes size -1. This is going to be the last item. I can actually remove this because it's useless now. Let's go back to QML and check again. We should update the title here to say version 2 because that's what it is. And let's save everything and try to build our application. This is the first time we build it. We've done quite a lot, so we might get some errors, but don't worry, we're going to fix them if they are there. Let's bring out the compile output, and yes, we have an error. Let's look at issues we have. Why can't we create a joke like this? Let's find this constructor and see that we can't create a joke like this by passing in a string because we didn't define this constructor. Let's create it. We can actually modify this function to take a string. So we're going to say const qstring reference and call this joke. We are going to go to the CPP file and modify it as well. It's going to be exactly the same. And we should initialize the string for the joke, which is here, to what we passed in the title there. The way we do that, we use the initializer list we have here. So we're going to say mjoke and initialize that to joke that we passed in the parameter here. Let's try and build again. And right now it looks like we didn't include this method. So let's go back to app wrapper and see if we can find them. Yes, they are here, and we forgot to put them in there. We can actually copy all this and bring that to data source CPP. Let's go to the top here and put that in here. And you can see that refactoring, you can easily introduce errors. That's why I am leaving things like this in here in case I have a problem, so that I can go and copy stuff and bring them over. Let's build again. Hopefully we're not going to have any more errors. We have an error here. What is this? Here we are trying to append a string to a list of joke objects, and this is not going to work. What we should do is to call the method that we have on top here, I think, that takes a string and adds that to the list. We should call add joke and pass in the string. So this is going to be very easy to fix. We're going to say add joke and pass in the joke that we want to add. And this is going to be fine. And down here, we don't need to reset the model. The model class is taking care of updating these things for us. Let's comment this out, build again, fingers crossed. Let's see what we have here. Here we should pass in 2 pound symbols. Let's do that. Let's build again. I have many errors, but this is part of the job when you are refactoring your code. And I think it's a good learning chance for you to see how you do these things in the real world. Okay, it looks like we have a clean build now. Before we run it, I want to set our expectations. We have a user interface here. When we run it, we're going to have a list viewed that is empty with nothing inside. When we click the fetch button, we are going to fetch the jokes, and the number is going to come from the spin box here, and it should automatically populate our list, and we should have the capability to remove the last joke. Let's run, fingers crossed. We have the user interface here. And if we fetch, let's fetch 5 jokes. This is going to be fine. And you see here, they say fetch posts is not a property of data source. It turns out this function is not available in my data source. So it is another error that I have. Let's go back to our data source. And our method is called fetch jokes. It's not fetch posts. Let's change this. Remove last. Let's make sure we have this also so that we don't have the same error. It's not remove last. It is remove last joke. We renamed things a little bit. Let's run again. Hopefully it is going to work now. Let's change this to 5 and fetch again. And ladies and gentlemen, our application is working. You see that we are getting the jokes. Let's try to remove the last joke and see what we get. And you see that we are removing jokes. And all this is backed by a C++ model, a complete C++ model that has the capabilities of updating the list view here in an efficient way without really wasting our resources. This is pretty cool. Now that we have this working, I'd like to go and clean up my mess here so I can safely remove this and safely remove these things because I don't need them anymore. Let's go down and remove all the junk that we don't need anymore in here. Clean up this space here. Let's go to the header and do the same. I am going to remove all this. I actually don't even need a signal in here, so I can clear up to there. Let's do this. We can remove all these includes. We don't need them anymore. App wrapper is done. Let's go to data source and see that we need to do some cleanup. Let's remove this list. Let's go down and remove all this. Be careful not to remove what you don't need to remove. Let's go up. It looks like what we have is what we need in here. And ladies and gentlemen, we should be fine by now. Let's go to the header. And this is all we really need to update our model to use. And this is all we need. What do we have here? We removed the include that we actually needed. So let's include this again. It's going to be pretty easy to do. Put it in here and build again. Let's open the compile output to see what is happening. We have a clean build. We can run it. We have our app here, and we should be able to fetch jokes from the internet using a completely custom C++ model that we have on the C++ side of our application. This is really all we had to do in this chapter. I hope it gave you a chance to practice things we have seen before. When you implement your own model, there are a few methods that you need to provide. We saw that. We saw how we can decouple the data source from the model. And we saw how we can put things together in App Wrapper, where we initialize the application, we create the data source, we link it to the model, and then we expose all we need as context properties, and we can safely use all this information on the Qt Quick side of our application. This is all we had to do in this chapter. Congratulations on getting here. You are really learning a lot. In the next chapter, we're going to see how you can create your own visual types. I'll see you in the next chapter.